welcome to lesson 26. This is over the division algorithm. So we're finally going to be getting into long division, and I promise, do not worry, we're going to be practicing this over and over again with the same steps, same questions for every single long division problem. That you'll have this down by the end of the year in no time. Alright, so one thing that we do want to remember is an algorithm is a way of solving a problem. So when I have a division algorithm, I have different steps I need to follow, and it continues over and over again. It always repeats itself, so that's the best part about it. So our first step that we do is we divide. We divide our numbers, and we'll go through these in our examples. Next step is we multiply, then we subtract, then we bring down. So way to remember them, this is dad, mom, sister, brother. So dad, mom, sister, brother. D for divide, M for multiply, S for subtract, and B for bring down. So I'm going to be going those over and over again with all of you so that we have that down, so that whenever you're doing your long division, remember dad, mom, sister, brother. And that way you'll be able to remember all the steps that you need to keep doing over and over again. They always repeat themselves. So the first one we're going to look at is $8.52 divided by 3. Now let me tell you a secret. When you have dollars and cents, you're actually never going to have a remainder. I know, it's pretty awesome. So $8.52 divided by 3, I know I'm not going to have a remainder. You can't have a remainder of cents, it's just random. So 3 goes into 8 how many times? That's what we ask ourselves for that's whenever we're dividing. The division part is how many times can I put 3 into 8? Well, if we count by 3s, 3, 6, 9, so I can't go in 3 times, I can only go in 2 times. My 2 goes at the top of the 8 because that's the numbers that I'm dividing right now. 2 goes right above the 8. Then I multiply the number that I just wrote down. Whenever I divided, it said 3 goes into 8 2 times. Now I'm going to multiply 3 times 2, and that's 6. So after I multiply, I then subtract. So I'm going to subtract 6. 8 minus 6 is 2, and then I bring down. Bring down my next digit. You're always going to bring down your next digit. Even if you just have zeros, you always bring down until we do not have any more digits to bring down. So I'm drawing an arrow because that's what I want you to do. I want you to draw arrows to start out with so that you know which digit I'm bringing down. We know step by step and we're not skipping steps. Then, after I bring down, guess what? I go all the way back to divide. 3 goes into now 25. We divide the number that we have right now, our current number here. 3 goes into 25 how many times? Well, I'm going to think 3 times 5 is 15. I always kind of start with the middle. It's a good thought process. If you don't, you know your multiplication facts off the top of your head. So 15 is too small. I need to go up a few more. Well, let's try 3 times 7. That's 21. I think I could probably get closer. So 3 times 8 is 24, and that's, I think, as close as I'm going to get. So 8 goes right above the 5 because that was the digit I just brought down. I do one digit, I should have one digit over each other at a time in my quotient. So I'm not going to squish them all together because then I'll get confused. I want to keep it nice and organized. That way I'll be able to do it correctly. So then I multiply the digit that I just wrote down times 3. So 8 times 3 is 24. And that's what I subtract. 25 minus 24 is 1. And then after I subtract, I bring down again. Bring down my 2, and it's 12. Well, thankfully, like I said, there's no remainders. 3 actually goes into 12 a whole amount of times. 3 times what is 12? And that should be pretty easy enough. It is 4. So 3 times 4 is 12. I put my 4 that's part of my quotient up at the top. I put it at the top above the 2 that I just brought down. 3 times 4, the digit I just wrote down is 12, and that's what I subtract. So 12 minus 12 is 0. Now I know to stop Because after I subtract, I'm supposed to bring down. Do I have any more digits to bring down? I don't, so that means I'm done. I subtracted, my answer is complete, except, of course, I need my labeling, right? Of course. So my decimal goes right above where it is in my answer. That's why we keep it all organized. And then I put my dollar signs. I have $2.84. That is example 1. Again, I always did divide, multiply, subtract, bring down, go back again. Divide, multiply, subtract, bring down, go back again. Divide, multiply, subtract, bring down. And if I don't have anything to bring down, I stop. That's it. So that's the thought process that we need to get through. We need to remember dad, mom, sister, brother. Dad, mom, sister, brother. We'll get it stuck in your head, I promise. Okay, so that is my quotient. The quotient of $8.52 divided by 3 is $2.84. Now I want you to go ahead and try example 2 on your own and see if you can get the correct answer. Okay, now this is when our divisibility rules kind of come in handy, because if a number is divisible by 5, remember what we learned. If a number is divisible by 5, it ends in a 5 or a 0. 234 does not end in a 5 or 0, so I know I'm going to have a remainder. I already know that right off of the bat because of our divisibility rules. So I'm always going to ask myself this question. How many times can 5 go into 2? It can't. So I'm going to go to the next 2 digits. That's what we do at the very beginning. If it can't go into my first digit, then I can look to the 2 digits together. How many times can 5 go into 23? Well, I know that 5 times 4 is 20. So I do 5 times 4, and that was my multiplication step. So now I'm subtracting. Subtract 20. Left over with 3. After I subtract, I bring down. I have a 4 to bring down here. How many times can 5 go into 34? It can go in 6 whole times. Then I multiply. 6 times 5 is 30. That's what I subtract. 34 minus 30 is 4. After I subtract, do I have anything else left to bring down? Of course not. I don't have any more digits to bring down, so that's my remainder. 46 remainder 4. That's when I know when to stop. I have no more digits to bring down, so that's what's left over. Okay, example 3. Remember what kind of problem this is. 5n equals 365. So this is 5 times n is 365. It ends in a 5. That means it's divisible by 5, and I will not have a remainder. Go ahead and try that in your red spirals. Alright, I'm going to do division to solve for it, because if I have an unknown factor in my multiplication problem, I need to use the opposite operation in order to solve it. So I'm going to do 365 divided by 5. I divide first. How many times can 5 go into 3? Well, it can't, so I'm looking at the next digit also. How many times can 5 go into 36? It can go in 7 times. 7 times 5 is 35, so that's what I subtract. 36 minus 35 is 1. After I subtract, I bring down my next digit, draw my arrow. How many times, back to division, how many times can 5 go into 15? It can go in 3 times. 3 times 5 is 15, and that's what I subtract. And like I said before, we have no remainder. I have no more digits to bring down, so I know my answer is complete. 73 is my answer. Now, what I do want you to be practicing on or remembering, some of you probably already know this and have practiced, is that proving your answer, whenever I prove my answer, I use the opposite operation. So I'm going to use my quotient times my divisor, and I will get my dividend. Remember, we're using the vocabulary. I use quotient times divisor, my 2 smallest numbers, and my answer should be my dividend. So that's how I prove my work. I'm going to go ahead and prove that. Off to the side, 73 times 5. 5 times 3 is 15. Carry my 1, bring down the 5. 5 times 7 is 35. 35 plus 1 is 36. That's 365, which is my dividend. That means these three numbers are indeed a fact family. My answer is indeed correct. Now, if I were to have a remainder, I would add it on after I multiply. So if I had like remainder 2, then I would do 365 plus 2 as my remainder. That's if I had a remainder, you add it on afterwards to get your dividend, the final number. All right, what I want you to do is practice set in your journals or in your spirals, and you're going to do A and B, 2 long division problems. Then you're going to skip all the way to I. I is you're going to prove this answer. So just like I showed you with here, except you have a remainder, you're going to prove to me, showing your work, how this is possible. So use the opposite operation. J and K, you have missing factors in a multiplication problem, so use the opposite operation in order to solve it. Thank you so much for paying attention.